Let us do question number 3. Arrange in ascending order. We are given these 3 numbers and we are asked to arrange this number in ascending order, isn't it? So if we have 3, 2 and 7, and if we are asked to arrange these numbers in ascending order, this means that 2 will come in the front, then after that 3 and comes 7. The smallest number will be in the front and the greatest number will be in the last. This is the ascending order. Smallest is smaller and then it moves on, isn't it? So this is how we arrange these numbers also, okay? What we do, how we arrange these numbers in ascending order, how would we know that which one is the smallest number and which one is the greatest number, isn't it? So let's do this. Let us write 5 whole 1 upon 2 and 10 whole 1 upon 4 and 6 whole 1 upon 3, okay? 5 to the power 1 upon 2, 10 to the power 1 upon 4, 6 to the power 1 upon 3. Let us take the LCM of 2, 4 and 3, okay? The LCM of 2, 4 and 3. The LCM will be 12, isn't it? Let me help you. 2, 4 and 3. So 2 1s are 2, 2 2s are 4 and this 3 comes down. So the LCM will be 2 1s are 2, 2 2s are 4, 4 3s are 12. The LCM will be 12. Now our main goal is to bring 12 in the denominator of the power, okay? That is what I am trying to say is 5 into 5 whole to the power 1 upon 2, 5 whole to the power 1 upon 2, isn't it? So to bring 12, to bring this number 12, what we do is we need to multiply with 6, isn't it? 2 6 are 12, 2 6 are 12. So we cannot write 6 as it is like this. So we need to balance this 6 by multiplying with 6. And this 6 and 6 gets cancelled, so 5 to the power 1 upon 2 remains as it is. Now here we have 10 to the power 1 upon 4. This number also we can do 1 upon 4 into, so to bring 12 in the denominator, what we write? We write 4 3s are 12. 4 3s are is 12. 4 3s are is 12, isn't it? So to balance this 3, I write 3 in the numerator as well. 6 whole to the power 1 upon 3, 1 upon 3. So to bring 12 in the denominator of the power, what I do is I multiply by 4. So 3 4s are 12. 3 4s are 12, isn't it? So to balance this 4, I need to put 4 in the numerator as well. Now this becomes 5. 1 into 6 is 5 to the power. 1 into 6 is 6, isn't it? 2 6 are 12. 5 to the power 12 equals to 1 into 3. Now let us try this 10 here. 1 into 3 is 3. 4 3s are 12. Are you getting me? Yes. 6. 1 into 4 is 4, isn't it? So 3 4s are 12. So we have 12 in the denominators of the power. This gives us, let me erase this now, okay? This gives us 5, this can be written as 5 to the power 6 whole upon 1 upon 12, isn't it? 5 to the power 6 whole to the power 1 upon 12. 5 to the power 6 whole to the power 1 upon 12. This means 6 1s are 6 into 12, okay? 12 is in the denominator. Similarly here, 10 cube whole to the power 1 upon 12, isn't it? So 3 1s are 3. 3 1s are 3. 10 cube into 1 upon 12. So here 6 to the power 4 whole to the power 1 upon 12. Our main objective is to bring the power 1 upon 12, make the power same, okay? This gives us 5 to the power 6 means 5 into 5 into 5 into 5, 1 2 3 4, 5 into 5, 5 to the power 6. 5 5s are 25, 5 5s are 25. 25 into 25 is 65, isn't it? This is 65. 6 to 5. And 5 into 5 is 25. Again we multiply with 25. So this gives us 5 5s are 25. 2, 5 to the 10, 11, 12, 2, 1. 5 6 are 30. This is 31. And 2 5s are 10. 2 2s are 4. 5 to 6 are 12. So we have 5, 2, 6, 5 and 1. 1, 5, 6 to 5, isn't it? 5 to the power 6 means 1, 5, 1, 5, 6 to 5. 6 to 5 whole to the power 1 upon 12. 10 cube means 1, 2, 3. 10 cube, 3 zeros, okay? 3 zeros, 1 to the power 1 upon 12. 6 to the power means 6 multiplied 4 times. Okay? 6 into 6 into 6 into 6, isn't it? 6 6 are 36, 6 6 are 36. So 36 into 36. 36 into 36. 6 6 are 36, 3 in hand. 6 3 are 18, 18 plus 3 is 21, isn't it? 19, 20, 21. So this gives us 3 6 are 18, 3 3 are 9, 10. 6 plus 9 to 1, 1 to 9, 6. 1 to 9, 6 whole to the power 1 upon 12. Here we have 15,625 whole to the power 1 upon 12, 1,000 whole to the power 1 upon 12, 1,296 whole to the power 1 upon 12. The power is same for all the numbers. Now we can simply say which number is smallest among these three numbers. Smallest is this number, isn't it? So first we write 10 to the power 1 upon 4. Then after, this is smaller, this is smaller. Then after, among these two numbers, this is a smaller number, so this comes from this 6 whole 1 upon 3. Then after, the greatest number is this, isn't it? 5 whole 5 to the power 1 upon 2. So this is the way how we write numbers in ascending order, okay? Smallest number and the greater and the greatest. Number 2 of 3. 3 to the power 1 upon 3, 2 to the power 1 upon 2, 8 to the power 1 upon 4. We are asked to arrange this number in ascending order, isn't it? So let us take the LCM of 3, 2 and 4. The LCM of 3, 2 and 4 is 12, okay? 3, 2 and 4 is 12. The LCM is 12. You know how to find the LCM, isn't it? 3, 2 and 4. So 3, 2, 1 the 2, 2 to the 4, 2 3 the 6, 6 to the 12. LCM is 12. Now our main objective is to bring 12, this 12 in the denominator of the power, okay? Our main objective is to bring this number 12 in the denominator of the power. This gives us 3. We have already 1 upon 3 in the power, isn't it? 3 to the power 1 upon 3. This is 3, 1 upon 3. So to bring 12 in the denominator of the power, I need to multiply with 4. 3 4 is 12, isn't it? To bring this 12, I need to multiply with 4. 3 4 is 12. So I cannot write 4 as it is like this. So we need to balance this 4 by simply multiplying it. So 4 and 4 cancels and 1 upon 3 remains as it is. So let's do the next one as well. 2 to the power 1 upon 2 can be written as 2 to the power 1 by 2. So I need to bring 12 in the denominator of this number also. So to bring 12 in the denominator, what I do is I multiply with 6. 2 6 are 12. So I cannot write 6 like this, so I need to balance this 6. 6 and 6 cancels out and 1 upon 2 remains as it is. Now I have another number that is 8 to the power 1 upon 4. This can be written as 8 to the power 1 upon 4 into, so I need to bring 12, isn't it? That means 4 3 is 12. 4 3 is 12. I cannot write 3 like this, so I need to balance this 3. 3 and 3 cancels and 1 upon 4 remains as it is, okay? Now 3 to the power 1 into 4. 1 into 4 can be written as 4, isn't it? 3 4 is 12. Okay. 2 to the power 1 into 6 can be written as 6 and 2 6 is 12. Here 8 to the power 1 into 3 is 3 and 4 3 is 12. So I have 12 in the denominators of the power of all numbers, isn't it? So this can be written as 3. So this power 4 is here, all to the power 1 upon 12. So 4 1s are 4 is in the numerator, okay? 4 1s are 4 upon this 12. Here also I can write like this, 2 to the power 6 into 1 upon 12. 6 is in the numerator, 6 ones are 6, 6 upon 12, 6 upon 12. Here also 8 to the power 3 upon 8 to the power 3 whole to the power 1 upon 12, isn't it? 3 ones are 3 to the power 12 upon 12. Okay, I hope you are getting me. This gives us 3 to the power 4 means 3 multiplied 4 times. 3 into 3 into 3 into 3, isn't it? That is 81. 3 to the 9, 3 to the 9, 9 9 is 81. So 3 to the power 4 means 81, 81 to the power 1 upon 12. Okay. Now 2 to the power 6 means 32, isn't it? 2 into 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to 64. Oh, 2 to the power 6 is 64. 64 whole to the power 1 upon 12. And 8 cube means 8 8 is 64. 8 into 8 into 8. 8 cube means 8 8 8, isn't it? 8 8 is 64. 64 into 8. That is 8 4 is 32. 3 8 6 is 48. 49 50 51. 512. This is 512 whole to the power 1 upon 12. So we are asked to arrange this number in the ascending order, isn't it? So the power is 1 upon 12, 1 upon 12, 1 upon 12. The power of all the numbers are equal. So let us see the numbers. Which one is the smallest among this? So 81 is the smallest. So this 81 comes from 3, isn't it? So 3 to the power 1 upon 3 is the smallest. And greater than this number is 64, isn't it? The 64 comes from this number, 2 to the power 1 upon 2. And after that, the greatest number is 512. And this comes from 8 to the power 1 upon 4. 1 upon 4, isn't it? So the smallest is 3 to the power 1 upon 3, and the greatest is 8 to the power 1 upon 4. Okay, these numbers in the ascending order. We can do in the simplest way, 2 multiplied 60 times, isn't it? 2 into 2 into 2 into 2 multiplied 60 times. We can do in that way also, but that is a really tedious method, isn't it? That is a really tedious method. So let us choose the simpler method to arrange this number in ascending order. Okay, we write as usual 2 to the power 60 and 3 to the power 48 and 4 to the power 36 and 5 to the power 24. Let us see. 2 to the power 60. Let us take the HCF of 60, 48, 36 and 24. Okay, HCF, highest common factor. Okay, HCF 60 means this can be written as 2 2s are 4, 4 2s are 4, 3s are 12, 12 5s are 60. 2 2s are 4, 4 3s are 12, 12 5s are 60. And the HCF of 48, LCF of 4, sorry, factors of 4, these are the factors. Okay, factors of 48, not 40, 48. Factors of 48 is 2 2s are 4, 4 3s are 12, 12 4s are 48, isn't it? 12 3s are 36, 12 4s are 48. Now comes 36. 36, 2 2s are 4, 4 3s are 12, 12 3s are 36. 2 2s are 4, 4 3s are 12, 12 3s are 36. Now comes 24. 24 means 2 into 2, 4, 4 into 2, 8, 8 3s are 24. So the HCF is the common number among these 3 numbers, 4 numbers, isn't it? So we have these 2 and this 3. Oh, this is 2, isn't it? So this 3. So HCF is this pair 2, this pair 2, and this pair 3. That is 2 to the 4, 4 to the 12. HCF is 12. So here we can write we need to bring 12 in the denominator, okay? 2 to the power 60 into 12 upon 12. Okay, are you getting me? I want to bring 12 in the denominator. So this is 3 to the power 48, isn't it? Into 12 upon 12. This 12 and 12 cancels out, and 60 as it is remains as it is. This 12 and 12 also cancels out, and 48 remains as it is. So here we have 4 to the power 36. This can be written as 12 upon 12. So 12 and 12 cancels, 36 remains as it is. 5 to the power 24, you can write 12 upon 12, isn't it? So let us cancel. 12 ones are 12, 12 fives are 60, 12 ones are 12, 12 fours are 48, 12 ones are 12, 12 threes are 36, 12 ones are 12, 12 twos are 24. This gives us 2 to the power 5 into 12, isn't it? This can be written as 2 to the power 5 whole to the power 12. And this can be written as 3 to the power 4 into 12. 3 to the power 4 into 12. 3 to the power 4 into 12. This can be written as 4 to the power 3 into 12. 4 cubed into 12. Are you getting me? 4 cubed into 12. So 5 square into 12, isn't it? This is 5 square into 12. I hope you are getting me. Now let's erase this, okay? Please take the screenshot if you want. Now the simplest thing is 2 to the power 5. 2 to the power 5 is 32. 2 into 2, 3, 4, 5. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. 32 whole to the power 12. This is 3 to the power 4. 3 multiplied 4 times, isn't it? That is 81. 3 into 3 into 3 into 3. 3 3s are 9, 3 3s are 9. 9 9s are 81. So this is 81 to the power 12. 4 cubed. 4 cubed means 64, isn't it? Let me do here. 4 into 4 into 4. 4 4s are 16, 16 4s are 64. Okay? This is 64 whole to the power 12. And 5 square means 25. 25 to the power 12. Now the power of all the numbers are 12, means the power is equal. Just we can see which is the smallest number. We'll write that number in the front. 32, 81, 64 and 25. 25 is the smallest among this number. So this 25 comes from this number, isn't it? 5 to the power 24 is the smallest number. And greater than this is among this number 32, isn't it? So 32 comes from 2 to the power 60. 2 to the power 60. And after that, among these two numbers, this is the smaller number. So 4 to the power 36. And in the last comes this number, 3 to the power 48. 3 to the power 48. So this is how we arrange the number in ascending order. Okay, I hope you got this. Question number 4, let us prove. We are asked to prove this equal to 1. This equal to 1. Okay, let's do. LHS equals to, LHS means left hand side, isn't it? LHS equals to a to the power q upon a to the power r whole to the power p, isn't it? So this can be written as a to the power, since the bases are same, so if you take this a to the power r to the numerator, the sign of the power changes to minus, isn't it? So bases are same, then the powers will be added, that means q minus r. This can be written as q minus r. A to the power q minus r, okay, into p. Are you getting me? A to the power this q minus r, because a to the power r was in the denominator. When you take this number to the numerator, the sign of the power changes to minus r. Now a and a base will be same, so power will be added. Q plus into minus r is minus r, q minus r. Now similar here, a to the power r minus p, r minus p. This is r minus p whole to the power q. okay, into this is a to the power p minus q, p minus q into this is r. Now let us multiply. A to the power p into q is pq minus p into r is pr into a to the power q into r is qr, isn't it? Plus into minus is minus, q into p is pq into this is a to the power r into p is pq, r into p is pr minus r into q is qr. Okay. Now this a bases are same, so you can add the powers, isn't it? A to the power p minus a to the power pq minus pr plus this power qr minus pq plus this power pr minus qr, isn't it? So this gives us minus pr plus pr cancels out each other, minus pq plus pq cancels each other, plus qr and minus qr cancels each other. So a to the power 0, isn't it? So a to the power 0 means 1. Anything to the power 0 is 1, except 0 to the power 0 is not equal to 1, okay? It is undefined. A to the power 0 is 1. I have you got this. 2 or 4, we are asked to prove this expression equals to 1, okay? This is LHS and this equals to 1. We are asked to prove this. These sums are very easy, okay? Left hand side equals to, since we have x to the power m upon x to the power n, bases are same, so x to the power n, if we take to the numerator, becomes x to the power minus n. Now since the bases are same, so power will be added, m plus bracket minus n, m plus into minus. I'll show you, okay? X to the power m into x to the power minus n, isn't it? If you take x to the power minus n to the numerator, it becomes x to the power minus n. This becomes, since bases are same x, so x to the power m plus, and this is minus n. This becomes x to the power m plus into minus is minus n, isn't it? This is what happens, okay? But we don't write all these steps, we shorten the steps. X to the power m minus n whole to the power m plus n. Let me write in this way, x to the power m minus n whole to the power m plus n, okay? Now x to the power here also n minus l, and this plus l goes to the numerator and becomes minus l, n minus l into n plus l, n plus l. This can be written as x to the power l minus m into l plus n, l plus n, isn't it? Plus n, when taken to the numerator, becomes minus n. Okay, now since we know the formula, a square minus b square equal to a plus b into a minus b. A square minus b square equals to a plus b into a minus b. So here a is m and b is n, okay? A minus b into a plus b. This can be said as a plus b into a minus b. This means x to the power a square minus b square, okay? Into, this can be written as x to the power a minus b into a plus b, isn't it? A square minus b square, and into x to the power l minus n, l plus n, l square minus m square. Are you getting me? So these bases are same, that means the power can be added. X bases are same, so power can be added. X to the power m square minus n square plus n square minus l square plus l square minus m square, okay? This is plus m square and minus m square can be cancelled. Minus n square plus n square minus l square plus l square. So x to the power 0, this is equals to 1. This is equal to right hand side, isn't it? Right hand side. This equals to right hand side. Right hand side we have 1. So this is proved, okay? This is proved. I hope you got this. Okay, now let us do question number 3 from 4. Okay, we are asked to prove this expression equals to 1. Left hand side equals to 1. Okay, and let's begin. It's very, very easy. LHS, left hand side equals to, since we have x to the power m upon x to the power n, if we take this x to the power n to the numerator, it becomes minus n, isn't it? So x to the power m minus n into m plus n minus l into, here we have x to the power n upon x to the power l, so this can be written as x to the power n minus l. If you take this x to the power l to the numerator, it becomes x to the power minus l, and the bases are same, so power will be added, n minus l. N plus l minus m into x to the power l minus n, l minus m into l plus m minus n. So this is the left hand side, isn't it? Now let me start from here. Okay, I'll try to convert this into this equation. Okay, a square minus b square equal to a plus b into a minus b. So x to the power, I'll multiply m minus n with m plus n, again m minus n with l, okay, separately. M minus n into m plus n, m minus n into m plus n, again minus l into this, minus l into m minus n, into, we have here x to the power, I will multiply this two again with this m minus n minus l into n plus l, again minus m into this, isn't it? So minus m into n minus l into x to the power l minus m into l plus m, l minus m into l plus m, again minus n into l minus m, minus m into l minus m. Okay, now let us write the formula. A minus b into a plus b equals to a square minus b square, isn't it? Let us multiply this also. Okay, minus l into m is lm, minus into minus is plus, l into n is ln, into x to the power n into, sorry, a minus b, a plus b is equals to a square minus b square, minus into plus is minus, m into n is mn, okay, minus into minus is plus, m into l is ml. Okay, now here we have x to the power a minus b, a plus b, isn't it? This is equals to a square minus b square, minus n into l is nl, minus into minus is plus, n into m is mn or nm, same thing. Okay, now since the bases are same, x, x and x, so power will be added. X to the power m square minus n square minus lm plus ln plus n square minus l square minus mn plus ml plus l square minus m square minus nl plus mn, isn't it? So this plus m square and this minus m square can be cancelled, minus n square and plus n square can be cancelled, minus lm and plus ml, same things. 2 3 are 6, 3 2 are 6, 2 either you write in the front or in later, 2 into 3 and 3 into 2, same thing. So similarly l into m or m into l, same thing. Minus lm plus lm cancelled, okay, plus ln into minus ln cancels. So this is minus l square and this is plus l square, cancels. Minus mn plus mn, both cancels, isn't it? So this gives us x to the power 0. So x to the power 0 means 1, isn't it? Anything to the power 0 is equal to 1, except 0 to the power 0 is not equal to 1. Okay, this gives us right hand side. hence it is proved. Right hand side equals to 1, isn't it? We were asked to prove 1, so this is right hand side, hence proved. Okay, 4 from 4, this is the last question from 4, isn't it? So we are asked to prove this equals to 1, isn't it? So in this type of sum, what we usually do is we have to write x, y, and then z, okay, and then x. So x minus y minus z, and z minus x. We should follow this order: x minus y minus z, z minus x. It is not mandatory to follow this order, but it becomes easier if you follow this order. Okay, x minus y minus z, and z minus x. So here, left hand side. Here we have a to the power 1 upon x minus y. A to the power 1 upon x minus y, isn't it? So here we have x minus z, so this should be in order z minus x, isn't it? So let us take the common, minus 1, isn't it? So when you take minus common, the minus number becomes plus and the plus number becomes minus. This becomes minus z becomes plus z, and this plus x becomes minus x. Okay, minus common. If I take minus common outside, this minus goes to the numerator, because minus sign doesn't remain in the numerator. If it is in the denominator, it goes to the numerator. Okay, similarly here also, a to the power z minus y minus z, isn't it? It should be x to the power x minus y minus z. Same thing, y minus z is correct, y minus z, isn't it? So into y minus x is the round formation here, isn't it? Let us reform this. So let us take minus common from this. If I take minus common, this minus x becomes plus x, this plus y becomes minus y. So minus cannot remain in the denominator, it goes to the numerator. Okay, into a to the power z minus x is the correct form, z minus x. Now here we have z minus x, isn't it? Z minus y. So let us take minus common and rewrite this as y minus z, y minus z, y minus z. Okay, when we take the minus common, minus y becomes plus y, plus z becomes minus z, and that minus goes to the numerator. Okay, now this minus 1 into 1 is minus 1, a to the power minus 1 upon this 2 can be multiplied, x minus y and z minus x. Okay, into a to the power minus 1 into 1 into minus 1 is minus 1. So y minus z into x minus y minus z into x minus y, into a to the power plus 1 into minus 1 is minus 1, z minus x into y minus z is z minus x into y minus z. Okay, this is not 2, okay, this is z. Okay, now since the bases are same, so power should be added, isn't it? So let us add the power. A to the power minus 1 upon x minus y, z minus x, plus, again then minus, plus into minus is minus, minus 1 upon y minus z, this y minus z, and this is x minus y, okay, y minus z, x minus y. Again the power will be added, plus into this minus becomes minus. Are you getting me? And this is z minus x, this is y minus z, isn't it? So we have x minus y, z minus x, y minus z, x minus y, z minus x, y minus z. That means the common LCM we can say x minus y, y minus z, and z minus x. This can be taken as LCM, isn't it? So here we have x minus y and z minus x, x minus y and z minus x. So we need y minus z, isn't it? So this minus 1 into x minus y and z minus x here. So we need this y minus z. This minus 1 comes here, minus 1 into, here we have y minus z and x minus 1, y minus z and x minus y. These two are here. We need z minus x, isn't it? Z minus x. So this minus 1 comes here. Again we have z minus x and y minus z. Z minus x and y minus z is there. We need x minus 1. X minus y. I hope you are getting me. Now equals to a to the power minus 1 into plus y is minus y. Minus 1 into minus z is plus z, isn't it? So minus 1 into plus z is plus z. Sorry. Minus 1 into plus z is minus z. Minus 1 into minus x. Minus 1 into minus x is plus x. Minus 1 into minus x is, sorry, minus 1 into plus x is minus x. Minus 1 into minus y is plus y. Whole upon xy, x minus y, y minus z and z minus x, isn't it? So this gives us minus y and plus y can be cancelled, plus x and minus x can be cancelled, plus z and minus z can be cancelled. So let me do here, okay? A whole to the power, this is 0, isn't it? 0 upon this, 0 upon xy, y minus z, x minus y, that will write a bigger, okay? Little bigger. A to the power 0 upon x minus y, x minus y, y minus z and z minus x, isn't it? X minus y, y minus z, z minus x, a to the power 0. So if you divide 0 by anything, 0 by 2 is equal to 0, 0 by x equals to 0, 0 by anything equals to 0, okay? If the number in the numerator is 0, then the whole thing becomes 0. So this is a to the power 0, a to the power 0 means 1. This equals to right hand side. This equals to right hand side. I hope you got this. We are asked to prove this is equal to 1, so a to the power 0 means 1. This is very simple question. You can understand very easily. We are provided with two conditions, x plus z is equal to 2y, and another condition is b square equals to ac, and we are asked to prove this equals to 1. Okay, let us use the given condition. Since we have x plus z equals to 2y, isn't it? This can be written as x plus z equals to y plus y. Y plus y gives 2y, isn't it? Or x, let us bring this plus y to the left hand side, it becomes minus y equals to y we have already in the right hand side, plus z if you take to the right hand side becomes minus z. So this x minus y equals to y minus z. Let us consider this as equation 1. Okay, now let us copy the left hand side of the question. Left hand side we have a to the power y minus z, isn't it, into b to the power z minus, let me write clearly, okay, b to the power z minus x into c to the power x minus y. Now let us write AC together because we have AC here, isn't it? Let us write AC together. A y minus z, a to the power y minus z into c to the power x minus y, and x minus y is y minus z. X minus y and y minus z are equal. So instead of x minus y, I can write y minus z, isn't it? So b to the power z minus x. Z minus x. This is from 1. I am using from 1, okay? From equation 1. Since x minus y equals to y minus z. So instead of this x minus y, the power of c is x minus y. Instead of x minus y, I wrote y minus z. Okay, I hope you got this. Now, if we have a square into b square, a square into b square, this can be written as ab whole square, isn't it? Do you know this? Yes, you know very well, isn't it? So now, what we do is, since the power of a and c are same, y minus z, so we write ac whole to the power y minus z, okay, and b to the power z minus x. Are you getting me? Yes. So ac, according to condition, ac means b square, isn't it? So instead of ac, I can write b square. Are you getting me? This ac means b square. So instead of ac, I write b square into 2y minus z. Okay, ac means b square into y minus z, into b z minus x, isn't it? Now let me continue here. Let us multiply this 2 with these two numbers. Equals to b, 2 into y is 2y, isn't it? Plus into minus is minus, 2 into z is 2z. Now we have b to the power z minus x into b to the power z minus x. Now since the base are same b and b, the powers can be added. So let us add the power. 2y minus 2z plus z minus x, isn't it? So b to the power 2y minus 2z plus z minus x. So 2y minus 2z plus z is minus z, isn't it? Minus x. Okay, so x plus z is 2y, isn't it? X plus z is 2y. I am using the first condition now. B to the power 2y. Now let us take common, minus sign common from this number. Minus is taken common. This becomes z plus x, isn't it? When I take minus sign common from this number, this becomes z plus x. Okay. Or b to the power 2y. This minus comes here. Z plus x or x plus z, same thing, equals to 2y, isn't it? Equals to 2y. This is the given condition. So b to the power 2y minus 2y is 0 and b to the power 0 is 1. Anything to the power 0 is 1 except 0 to the power 0 is not equal to 1. This is equal to RHS, okay? Hence proved. I hope you understood this. Okay, now let us do question number 6, okay? We are provided with this condition: a equals to this, b equals to this, and c equals to this, and we are asked to prove this equals to 1. Please note that this power p minus 1 is only for y and not for x. Okay, here the power q minus 1 is only for y and not for x. Similarly, this power is only for y and not for x. Okay, we must keep this in mind. So let us begin. LHS means left hand side equals to a to the power q minus r. Okay, let me write clearly. A to the power q minus r, b to the power r minus p into c to the power p minus q, isn't it? This is left hand side of the equation. I am going to use this and prove 1. Okay, now putting the value of a, b and c, putting the values of a, b and c. The value of a given to us is x into y to the power p minus 1, isn't it? So instead of a, I write x into y to the power p minus 1. This is a, isn't it? This is a. A means this. So this a is this. So a has the power q minus r. That means this a has the power q minus r. Are you getting me? I hope so. Into, we put the value of b, okay? b means x into y to the power q minus 1, isn't it? b means this. So instead of this b, I write x into y to the power q minus 1. So this is b. So b has the power r minus p. So this power goes to r minus p for b, okay? This is b raised to power r minus p. And instead of c means x into y to the power r minus 1. So this c means x into y r to the power minus 1. Sorry, x into y to the power r minus 1. This is c, isn't it? So c is raised to power p minus q. P minus q. I hope you are getting it. This q minus r is for both x and y. This power q minus r is for both x and y, but p minus y 1 is only for y, okay? This r minus p, this power r minus p is for both x and y because both are within the bracket, isn't it? So q minus 1 is only for y. Similar goes to here, okay? This is left hand side, isn't it? So let us put the power separately. If a b whole square is written like this, then we can write a square into b square separately, isn't it? So I am going to write in this form, okay? X y whole to the power q minus r. So this can be written as x to the power q minus r into y to the power p. Y already has p minus 1 power, so this should not be forgotten. P minus 1 into q minus r. Q minus r. Okay? This q minus r is for both x and y. Into, here also we write this r minus p separately to x and y. So x raised to power r minus p into y already has power q minus 1, isn't it? Q minus 1 into r minus p. Okay? It seems a little complicated, but it is very, very easy, believe me. This x into x raised to power p minus q into y to the power, y has this power also, so r minus 1 into p minus q. Now what we do is we write the powers of x together, okay? Since the base x and x base are same, so their powers will be added, isn't it? If a square into a cube, then we write a 2 plus 3, isn't it? So here x and x are same, so their power will be added. Similarly, the powers of y will also be added, okay? Okay, now let us add up the power. X to the power q minus r plus r minus p, isn't it? R minus p plus p minus q plus p minus q. Now comes y. Y to the power y, isn't it? Y to the power this plus this plus this. We add up the power. P minus 1, q minus r plus q minus 1, r minus p plus r minus 1, p minus q. Okay? Now, plus q and this minus q can be cancelled, plus minus r and plus r can be cancelled, minus p and plus p can be cancelled. So x to the power 0, isn't it? So x to the power 0 into y to the power, let us multiply this, okay? P into q is pq, y to the power pq. What we do is we multiply with this p to both the numbers, and after that we multiply with 1 with both the numbers, okay? With minus 1 with both the numbers. P into q is pq, so plus into minus comes minus. P into r is pr. Are you getting me? So minus 1 into q is minus q, isn't it? So minus into minus is plus, 1 into r is r. Now comes this, isn't it? So q into r plus q into plus r is plus qr, and plus q into minus p is minus pq, minus 1 into plus r is minus r, minus 1 into minus p is plus p. Okay, minus into minus is plus, so 1 into p is p. Now comes here, plus, this plus comes here, r into p is pr or rp, same thing. Plus into minus is minus, r into q is qr or rq, same thing, isn't it? Now comes minus, minus into plus is minus, 1 into p is p, minus into minus is plus, 1 into q is q. Isn't it? So this pq and this minus pq can be cancelled, and this minus pr and this plus pr can be cancelled, and this minus q and this plus q can be cancelled, this plus r and this minus r can be cancelled, plus qr and minus qr can be cancelled, so this plus p and minus p can be cancelled. So we have x to the power 0 into y to the power 0, isn't it? So x to the power 0 means 1 into y to the power 0 means 1, so 1 into 1 is 1 equals to right hand side, isn't it? I hope you got this. This was very simple, isn't it? Okay, we have another very easy sum here. Question number 7. If x to the power 1 upon a equals to y to the power 1 upon b equals to z to the power 1 upon c and x, y, z equals to 1. These two are the given conditions, and we are asked to prove a plus b plus c equals to 0. Okay, we are asked to prove this. This is very easy sum. Okay, first of all, let me tell you that if a square equals to 2, suppose I'm just giving an example. Okay, a square equals to 2, then what we do is a equals to root under 2. This square, when taken to the right hand side, becomes root 2, isn't it? Root 2 can be written as 2 to the power 1 upon 2. That means if a square equals to 2, then I can write therefore a equals to 2 to the power 1 upon 2, isn't it? A square means 2, a equals to root 2, this square goes to right hand side and becomes root. Root means 1 upon 2, and 1 upon 2, a equals to 2 to the power 1 upon 2, isn't it? This is the way how we do. So this means if root a equals to 2, this is just an example, okay? Root a equals to 2, then a equals to 2 square, isn't it? Root a equals to 2, then root a equals to 2 means root when taken to the right hand side becomes squared. A equals to 4. Are you getting me? I hope so. So this can be written as in this form. Root a can be written as 1 upon 2. Root a means a to the power 1 upon 2 equals to 2. So a equals to this 1 upon 2 when goes to the right hand side becomes 2 square. So a equals to 2 to the power 2 square means 4, isn't it? 4. Yes. Now let's begin the sum, okay? We have, since x equals to x to the power 1 upon a equals to y to the power 1 upon b equals to z to the power 1 upon c equals to k, isn't it? Let, this is supposing, I am supposing this is k. X to the power 1 upon a equals to y to the power 1 upon b, okay, this is b. Y to the power 1 upon b equals to z to the power 1 upon c equals to k. This is say. This is say. Okay, now let us write separately. X to the power 1 upon a equals to k, comma, y to the power 1 upon b equals to k, and z to the power 1 upon c equals to k, isn't it? So x equals to, I told you earlier, if a to the power 1 upon 2 equals to 2, then a equals to 2 square, isn't it? That means x equals to k to the power a, isn't it? 1 upon 2 becomes 2, then 1 upon a becomes a. So 1 upon a goes to the right hand side and becomes a. So similarly, y to the power 1 upon b equals to k, then y equals to k to the power b, and z to the power 1 upon c equals to k, then z equals to k to the power c, isn't it? So now we use this, okay? Since x, y, z equals to 1, or x means k to the power a, k to the power a, putting the value of x, y and z, okay. X means k to the power a into y means k to the power b, k to the power b, not b. Y means k to the power b into z means k to the power c, isn't it? So k, bases are same, so their power will be added. K to, oh, this is equal to 1, isn't it? This is equal to 1. K to the power a plus, we write or here, a plus b plus c. Since the bases are same, so their power will be added. A plus b plus c equals to, this one can be written as k to the power 0, isn't it? Anything to the power 0 equals to 1, except 0 to the power 0 is not equal to 1. So k and k are same, their bases are same, that means their power will sorry, k and k are equal, isn't it? So their power will also be equal. Therefore you can write a plus b plus c equals to 0, hence proved. Did you get me? Since k and k are same, so they are equal, then their power will also be equal. Now let us do question number 8. This is similar to question number 7, okay. A to the power x equals to b to the power y equals to c to the power z, and abc equals to 1. These two are the given conditions, and we are asked to prove this equals to 0, okay. Now let a to the power x equals to b to the power y equals to c to the power z equals to k. This equals to k, okay. Now this means a to the power x equals to k, comma b to the power y equals to k, comma c to the power z equals to k, isn't it? This equals to this equals to this equals to k, means this equals to k, and this equals to k, and this equals to k. So, or you can write a equals to k to the power 1 upon x, isn't it? If you have a square equals to 2, then a will become the root. This means a equals to 2 to the power 1 upon 2, isn't it? Similarly, if a to the power x equals to 2, then a equals to 2 to the power 1 upon x. This 2 becomes 1 upon 2, this x becomes 1 upon x, okay? So a equals to k to the power 1 upon x, comma b equals to k to the power 1 upon y, and c equals to k to the power 1 upon z, okay? Now let us use this condition. Since a, b, c equals to 1, isn't it? A, b, c equals to 1. So a is k to the power 1 upon x. A means k to the power 1 upon x. Into b means k to the power 1 upon y. K to the power 1 upon y. Into c means k to the power 1 upon z. K to the power 1 upon z. Equals to 1. Equals to 1. So k, bases are same, that means power should be added. K to the power 1 upon x plus 1 upon y plus 1 upon z. If the bases are same, then the power can be added, isn't it? So this equals to 1 means k to the power 0. Anything to the power 0 is 1. So let me erase this and continue my sum, okay? Okay. Since this k and this k are equal, so their powers will also be equal. That means 1 upon x plus 1 upon y plus 1 upon z equals to 0. Or you can write 1 upon x plus 1 upon y plus 1 upon z equals to 0. 1 upon x plus 1 upon y plus 1 upon z equals to 0. Or let us take the LCM x, y, z, isn't it? X, y, z. Now we have x into yz equals to xyz, so yz into 1, yz, plus we have y here, y into xz is xyz, so xz into 1 is xz, isn't it? So plus z into xy is xyz, that xy into 1 is xy equals to 0. Or let us cross multiply this here, okay? Now xy, let us write this xy in the front, plus yz, let us write this yz here, yz, plus this xz can be written as zx, isn't it? Xz and zx are same, so zx equals to xyz into 0 equals to 0. So this is proved. I hope you understood. Question 1 and 2 of 9, okay? We are asked to solve. Solve means we are asked to find the value of x, okay? These are very, very easy sums. 49 to the power x can be written as 7 square to the power x, isn't it? 7 square means 49. 7 square means 49. This x is here, equals to 7 cube. This gives us, oh, this is OR. This is an equation, so we should put OR. 7 to the power 2 into x is 2x equals to 7 cube. Since the bases are same, 7 and 7 are equal, so their power should be also equal. Therefore, 2x equals to 3, or x equals to 3 upon 2. Since this is an improper fraction because the number in the denominator is smaller than the numerator, so we must convert this into mixed fraction, or x equals to, you can say 1 whole 1 upon 2. 2 1s are 2 plus 1 is 3, isn't it? So this is the value of x. I hope you got this. Now let us do this question. Since 2 to the power x plus 2 is 2 to the power x into 2 to the power 2, isn't it? Since the bases are same, so power can be added, x plus 2. This is actually this, isn't it? So this can be written as plus 2 to the power x into 2 to the power minus 1 equals to 9. Okay? 2 to the power minus 1 goes to the denominator, isn't it? Are you getting me? Yes. Now let us take 2x common. Oh, this is also OR, okay? Not equal to OR. 2x and 2x can be taken common. So 2 to the power x, 2 to the power x is common. Within the bracket remains 2 square means 4 plus, here 2 to the power x is taken common. So 2 to the power minus 1 means 1 upon 2, isn't it? Plus 1 power when taken to the numerator becomes minus 1, so equals to 9. Or 2 to the power x, let us consider 1 in the denominator of 4. When there is no number, there is always 1, isn't it? 1 plus 2 is, LCM of 1 and 2 is 2. So 2 4s are 8 plus 1 1s are 1 equals to 9. Now 2 to the power x equals to, we have to cross multiply this, 2 9s are 18 divided by 8 plus 1 9 comes in the denominator. 8 plus 1 9. So 9 1s are 9, 9 2s are 18, isn't it? Or 2 to the power x equals to 2 means 2 to the power 1 and 2 to the power 1 means 2. Therefore, since 2 and 2 are same, their power will also be equal. X equals to 1. This is the answer for question number 2. Okay. So question number 3 of 9. We have 2 to the power x plus 1, 2 to the power x plus 2 equals to 48. Or this gives us 2 to the power x into 2 to the power 1 plus 2 to the power x into 2 to the power 2. The bases are same, power will be added, x plus 1. Bases are same, power will be added, x plus 2, isn't it? So this is 48. Or let us take 2x common from here. 2x common, not 2x, 2 to the power x common. So within the bracket remains 2 to the power 1, that means 2 plus 2 square means 4. Isn't it? Equals to 48. Or we have 2 to the power x equals to 48. 2 plus 4 is 6, isn't it? This 6 goes to the denominator because there is into sign here. 6 1s are 6, 6 8s are 48. Or 2 to the power x can be written as 8 means 2 cubed. 2 cubed is 8. So here base 2 and 2 are equal, so their powers will also be equal, or x equals to 3. This is the answer for question number 3. Okay. Question number 4 of 9. These are very, very easy sums. Okay. Let us bring cross multiply this 2 to the power 3x to the numerator here and 4 to the power 3x minus 1 to the denominator. Okay, cross multiplication, simply cross multiplication into 2 to the power 3x. This 2 to the power 3x goes here, this number comes down, equals to 4 to the power 2x upon 4 to the power 3x minus 1. This goes here and this number comes down. Cross multiplication, isn't it? Or now the bases are same, so power can be added. 2 to the power 4x plus 3x, isn't it? Here bases are same, so power can be subtracted because this is in the denominator. 4 to the power 2x minus this power goes 3x minus 1, isn't it? Or 2 to the power, this can be written as 7x. 4x plus 3x is 7x. 4 to the power 2x minus into plus is minus 3x, minus into minus is plus 1. Or 2 to the power 7x equal to this 2, this 4 can be written as 2 squared, isn't it? Into 2x minus 3x is minus x, isn't it? Plus 2x minus 3x is minus x, and this is plus 1. Okay, so this 2 squared is 4. Okay, now since this base and this base is equal, 2 and 2 are equal, so the powers will also be equal. Okay, this can be written as 7x equal to 2 into minus x is minus 2x plus 2 1s are 2, isn't it? Or 7x, let us bring this 2x equals to 2. Excuse me. Minus 2x, when we brought to the left hand side, it becomes plus 2x. 7x plus 2x is 9x, isn't it? So this is 9x. Or 7x plus 2x is 9x equals to 2. 2, isn't it? 7x plus 2x is 9x equals to 2. Or x equals to 2 upon 9. This is the proper fraction since the denominator is greater number, so we don't have to change this into mixed fraction. This is the answer, okay, for question number 4. Question number 5 of 9. This can be written as 9 into 81 means 9 squared, isn't it? 9 squared, let us not write 9, okay? 3. 3 to the power 4 is 81. 3 to the power 4 is 81, and this x comes here. Equals to 27 means 3 to the power 3. 3 3s are 9, 9 3s are 27 into 2 minus x, okay? So 9 into 3 to the power 4x equals to 3 to the power 3 2s are 6 minus 3 into x is 3x. Are you getting me? 3 cube, 3 2s are 6. 3 into minus x is minus 3x. Now let us write this. 9 into 3 to the power 4x equals to 3 to the power 6 divided by 3 to the power 3x, isn't it? This minus 3x was in the denominator, so when you brought to the numerator, this plus 3x changed to minus 3x, 6 minus 3x. Bases are same, isn't it? So let us cross multiply this. 3x, let us bring this 3x here and 9 to the denominator, okay? Now 3 to the power 4x into 3 to the power 3x equals to 3 to the power 6 divided by 9. 9 means 3 squared, isn't it? 3 squared is 9. Or since the bases are same, so power can be added. 3 to the power 4x plus 3x equals to 3 to the power 6 minus 2. 6, this plus 2 becomes minus 2. Since the base are equal, so power also should be equal. Since the base are equal, 3 and 3 are equal, so their powers would also be equal. 4x plus 3x is 7x. 7x equal to 6 minus 2 is 4. Okay, so x equals to 4 upon 7, isn't it? So x equals to this 4 is here and this 7 comes to the denominator. So this is the answer for question number 5 of 9. Okay, these are very simple questions. Or 2 to the power 5x plus 4 equals to 2 to the power 10. Let us take this plus 2 to the power 9 to the right hand side. It becomes 2 to the power 9, isn't it? Or 2 to the power 5x plus 4 equals to, let us take 2 to the power 9 common, 2 to the power 9 common, and within the brackets remains 2 to the power 1 minus 1, isn't it? 2 to the power 9 into 2. 2 to the power 9 into 2 means here we have power 1, isn't it? So bases are same, power will be added, 9 plus 1 is 10. This gives 2 to the power 10. Minus, plus into minus is minus. 2 to the power 9 into 1 is 2 to the power 9, isn't it? So I don't think so you need explanation for this. 2 to the power 9 is taken common. So this gives us 2 to the power 5x plus 4 equals to 2 to the power 9. Because 2 minus 1 is 1, 1 into 2 to the power 9 is 2 to the power 9. So, or since 2 and 2 are equal, so their bases are equal, means power should be also equal. 5x to the 5x plus 4 equals to 9. This gives us x equals to 9 minus 4, isn't it? 9 minus 4. This plus 4 becomes minus 4, and this 5 into comes to the denominator. So this gives us x equals to 9 minus 4 is 5 upon 5. 5 upon 5 is 1. Therefore, x equals to 1. This is the answer for question number 6 of 9. Now let us do question number 7 of 9, okay? Here we have 3 and 2, here we have 6, isn't it? So let us break up this 6 into 2 into 3. Whole to the power 2x plus 4. 2 into 3, 2 into 3, 6, isn't it? 2x plus 4 remains as it is. 3 to the power 3x into 2 to the power x plus 8. So we can write this power separately to both the numbers. 2 to the power 2x plus 4 into 3 to the power 2x plus 4 equals to 3 to the power 3x into 2 to the power x plus 8, isn't it? So let us bring this 2 to the power x plus 8 to the denominator and this to the other side denominator, okay? Cross multiplication. 2 to the power 2x plus 4. Let us cross multiply this and bring to the denominator 2 to the power x plus 8, okay? Equals to 3 to the power 3x upon 3 to the power 2x plus 4. Now we have 2 to the power, since the bases are same, so if you take to the numerator, the power changes to minus sign and it will subtract, isn't it? 2 to the power 2x plus 4 minus x plus 8 equals to, here this same thing happens, 3 to the power 3x minus 2x plus 4. Okay, now let me continue here. Let me do the last line here, okay? This is OR. 2 to the power 2x plus 4 minus into plus is minus x minus into plus is minus 8 equals to 3 to the power 3x minus into plus is minus 2x and minus into plus is minus 4. Are you getting me? Yes. Now let us write this here, or 2x minus x is x. 2 to the power x, isn't it? 2x minus x is x. This x. 2x minus this x is x. So plus 4 minus 8 is minus 4, isn't it? Minus 8 plus 4. Opposite sign. 8 minus 4 is 4. Sign of greater number comes. So equals to 3 to the power 3x minus 2x is x minus 4. Now here the powers are same. Don't say that their bases will be equal, okay? If their bases are equal, then power can be equal, but then if their powers are equal, bases cannot be equal. Please keep this in mind. If a square equals to a to the power n, okay, then their bases are equal, then power can be equal. But in this case, powers are equal, that means bases cannot be equal. Okay, just the opposite is not always true. Okay, this means let us break up this now. 2 to the power x upon 2 to the power 4, isn't it? This is 2 to the power x upon 2 to the power 4. Plus 4 becomes minus 4. This is 3 to the power x upon 3 to the power 4, isn't it? So let us cross multiply. 2 to the power x upon 3 to the power x, isn't it, equals to 2 to the power 4 goes to the numerator upon 3 to the power 4. Or this can be written as 3 power x, isn't it? So 2 upon 3 whole to the power x equals to 2 upon 3 whole to the power 4. 2 upon 3 whole to the power 4. Since their bases are equal, now their power can be equal. Therefore, x equals to 4. Please remember, if the bases are equal, then the power can be equal. But if the powers are equal, bases can be equal or can never be equal. This is not always true. Okay, if powers are equal, then bases can not be always equal.